Here we go. Hello, everyone. On behalf of IBM Systems Magazine, I'd like to welcome you to our presentation. My name is Janine Donnelly. I am the manager of webinars for IBM Systems Magazine, and I will be the moderator for today's event. We will be holding a Q&A session at the end of the webinar. You may ask a question at any time during the event by entering it into the Q&A panel. If you experience technical difficulties during the webinar, please use the Q&A panel to alert us, and someone will assist you. You may download a PDF version of the slide deck by clicking on the drop-down menu labeled Event Resources on the left of your screen. Also, be sure to check out the Event Resources tab for other valuable resources related to today's topic, and you can download those right from the platform without leaving the webcast. Today's webinar is sponsored by BMC Software. Send your mainframe outages into early retirement with automation. Our featured speaker today is Paul Spicer. Paul is the lead product manager for BMC Z Solutions optimization products and is focused on MainView and intelligent capping. Paul has over 30 years of experience working with IBM mainframe systems and building and managing systems management solutions. Today, Paul will discuss how automation is the key to ensuring top-notch availability for your mainframe. So with our introduction complete, Paul, I'll turn the presentation over to you.
Thanks, Janine. Today I would like to talk to you about automation, and just want to sort of start off with a quick overview of what I'm going to talk about today. So just a few things really on the agenda. Just a little bit of talking about how the world has changed over the last few years and how the need for automation has changed with that. Then we'll spend a little bit of time talking about the current state of systems management and what people are doing today. And leading into that, we talk about kind of where we really need to get to, what the desired state is for systems management, automation in particular. And then I'll kind of talk through some of the solutions we have and the automation maturity model, and then talk about some of the solutions we've got before turning it over for Q&A. So a lot to cover, and let's get going. So according to a 2016 State of DevOps report, high-performing IT teams do about 200 times more code deployments than others. So that's a pretty radical difference and sounds very impressive, but I guess the question really is, why does that matter? And when we look at this, businesses are doing this to keep up with the demands of digital business, but it means new and changed applications are rolling into production with a much greater frequency than ever before. Now, maybe they're all much smaller changes, but we all know that any change can add risk. So, lots of changes could potentially add a lot of risk. Of course, on the flip side, if you aren't making frequent application changes, you aren't introducing new IT risk, but it could mean your business risks falling behind the digital curve, and perhaps more importantly, behind your competitors. So, because of this market dynamic, we believe that there really needs to be better ways to manage IT, and that's really the purpose of this webinar and what I'm going to be talking about today. So here are some numbers that we just received from our soon-to-be-announced 2017 annual mainframe survey. It's a survey we do every year. We've been doing it for many years now. This year again, we had well over 1,000 respondents, and the numbers that we're looking at on this screen here are from survey respondents who report their mainframe MIPS are growing. And we can see, it sort of stands out fairly quickly. Transaction volumes are increasing for most of these people, driven by digital business, which kind of makes sense really when you think about how easy it is to drive a mainframe application from just about anywhere, including from your phone, mobile devices, that kind of thing. And it's things like, tracking a package, buying just about anything you can think of, checking flight statuses, or any one of the many things that result in back-end transactions are really driving up those increasing transaction volumes. And likewise, the amount of data is also increasing along with that. In other areas, volatility and unpredictability transactions coming in is also increasing by the same amount as those other two categories. And really, again, that makes sense. No longer are transactions tied to someone sitting behind a desk, 9 to 5 kind of thing. We all do it, right? We drive transactions sitting at home on the sofa, perhaps on a train, even on a plane these days, in a restaurant. It's literally anywhere and at any time, transaction workloads are coming into the mainframe. I mentioned on the previous slide that faster application change rates as well, and you can see that the majority of the growing companies are also reporting this in this year's survey. And then also, there's things like new technologies such as Java, which are changing the way systems are being developed and ultimately changing the way that systems need to be managed. So with all these changes going on, it's quite clear that systems management has to change to better keep up with this so that we can continue to effectively manage our systems. So, my view on this is that automation is the only answer. And again, looking at some of the numbers from our upcoming survey, and you're all getting a quick preview of this. The actual survey is going to be released in November, so not far away now. But just a couple of things to call out from the survey. IT professionals are saying cost is still number one. It's been the case for quite a few years now. But availability, as you'd expect, is still a top 3 mainframe priority. And for people that identified themselves as executives in the survey, automation was one of the top priorities for them, really for 2 reasons. One, to continue to improve availability, but also to address some of the skills issues that they're starting to see. So we're going to get more into that as we go forward. So when I look at the current state of systems management, this is kind of like observations on what we see from talking to companies in general across the industry. And really, first of all, you need to recognize there's a problem. Now, most people have some sort of alarming or triggering in place to detect problems, although even with that, all too often, maybe the first thing you hear is a call from a user that's saying, hey, we've got a problem with such and such an application. If you are using alarms or triggers, the chances are they're static, so they're set with values that are defined to be higher than the highest peaks that you ever expect, because obviously you're trying to avoid false alarms. There's also a good chance that these static alarms were defined perhaps some years ago. These days, not many people have the time to periodically go back and check to make sure all their alarms and triggers are still valid. But of course, the big question is, do the values still make sense? Do you have what we call normal red lights? That's a situation where perhaps an alarm was set many years ago and now always show red, so everyone just knows to ignore them because they don't mean anything. Obviously not really what it was intended to do in the first place. And then, of course, worse still, maybe there's some people out there that have very few alarms or triggers set in place, or perhaps even next to nothing at all. Maybe you're relying on people manually keeping an eye on the monitors to make sure it's running, as it should do. But no matter where you fit in that spectrum, I'm sure you wish there was ways to have better identification and notification of problems. So once you've got a real problem, the next thing is to figure out what's causing it. And what we see is because problem notification often takes a long time after the actual cause of the problem, it can actually be fairly difficult to determine the cause. So today, this likely means war room style calls. Everyone's sitting there looking at their own monitors, trying to figure out, what happened, what went wrong. And that can obviously take quite some time. And then finally, the last step here is resolution, which is usually going to be a manual process. And I think while it'd be great to have an automated resolution, there's really a couple of problems with getting to that. First of all, it's hard to trust automation to do the right thing. Now, that's not because automation makes mistakes, but it's because you can't be sure that the automated response you've defined is exactly the right response for the specific problem instance. So it kind of gets tricky. And you want to have eyes on the system to make sure that what you're doing is actually the right thing. Perhaps automation in most shops is limited to fairly straightforward basic console automation, like suppressing messages and issuing simple kind of command replies, that kind of thing. And then, the second part of automation is actually writing automation can be hard. Most people I talk to don't want to write and maintain lots of complex scripts. I mean, they just don't have the resource to do that kind of thing anymore. So, continuing on looking at current state of systems management, it's also made a lot harder because most companies don't have the same level and numbers of people that they used to. And from surveys, we've seen the scale and scope of management has increased significantly. Since 2005, the number of MIPS per employee has increased an amazing fourfold. So it's a big change. And also, again, talking to customers, we're also seeing that people are starting to retire at a faster rate. And when these people are replaced, they're typically replaced with someone who has a lot less experience. And again, there's something from our survey, another piece of information from that. We're seeing that 71% of survey respondents say it takes 2 or more years to train mainframe technicians. So clearly, when you look at all this in context, it's a lot of challenge, for a lot of companies. So okay, we've talked about the challenges caused with the current state. So now let's take a look at the desired state and where we want to get to with systems management. So first of all, problems will be proactively notified in the desired environment. There won't be any false alarms, and problems will be much easier to identify the actual cause because we're identifying them closer to when the problem actually occurred, not hours later when it's difficult to figure out what actually happened. I see also alarms and triggers will also be highly accurate and focused on the cause of the problem, identifying something very specific as being abnormal as early as possible. It won't be just something generic like a slow response time or something like that. And because accurate alarms and triggers were going to help identify the root cause, it should eliminate the need for war rooms for the most part and provide enough trust and understanding that it's also easy to take automated action. And then the final part, of this is that you won't need to write complex scripts to handle automation. It'd just be, at least a very simple fill-in-the-blanks type of approach to creating automation. So it's going to require less expertise, and it'll be much easier to understand and maintain, many years down the road. So with that, I wanted to just pause for a minute there, and we have a poll. So Janine, I'd like to turn it back over to you to run the poll for me, please.
Great. Okay, so as you can see, we have launched a poll. We're looking for your input to this question. What's the state of your automation? So go ahead and click all that apply, and we will be sharing those results with you. Just a reminder, too, to check out that Events Resources tab. If you did join late, you can click on Event Resources. It's on the left side of your screen. From there, you can get a PDF of the slide deck, and there's also some other data sheets in there that should be of interest to you. And I think we're ready to go ahead and launch these results. So we'll send the results out to the audience, Paul.
Okay. Yeah, so looking at the results there, I mean, that pretty much aligns with the kind of things I was talking about. Most people using static alarms. There's very few people that don't have alarms at all, and perhaps they're not updated quite as often as everyone would like. So I guess that's good that the kinds of things that we're seeing and hearing here pretty much match up with what I'm seeing. So let's go to the next slide. I want to talk a little bit about some of the challenges. We all want to sort of get to this ideal state, but what are some of the challenges in terms of getting there? And that's really the focus of this slide. So the first challenge obviously is to recognize there's a problem, but recognizing it before it becomes a big problem. So today with the static alarms or triggers, which is kind of represented by the red line, the red straight line on the chart here, you have to set the alarm higher than the expected highest peak to stop those false red conditions occurring. But again, if we look at this chart, we'll see that normal CPU usage is represented by that sort of grayish, whitish kind of color line. And you can see from the chart that the actual CPU, which is the orange line, has been above normal for a very long time. But you aren't getting notified about it with a static threshold, and because that isn't reached until pretty much close to the busiest time of the day, probably when you have the most people being impacted by the problem. So clearly not an ideal situation. So if you had a dynamic threshold set, you would see the deviation from normal as soon as it happens, which in my little scenario here is at 6 a.m. So obviously at this time the system is going to be a lot less busy, so you're catching the problem before the impact is as high. Another challenge is having trust in automations we talked about, and that really goes back to the first 2 points. If you're only finding problems well after they occur, you can't automatically pinpoint cause, and you can't really automate the resolution. So it has to be done manually, and typically that's going to be done by someone with expert level skills. So let's assume at this point we know what action to take, but the next challenge of doing this is actually writing the automation to do it. Perhaps you don't have the skills to write and maintain the Rex or other scripting language, and it's just generally too hard to go in and reliably create automation to fix those kinds of problems. So, I've talked about quite a bit about the desired state and the challenges of getting there. So I want to just kind of give an overview of how MainView has evolved specifically to help address the challenges that I've just been talking about. So, MainView is designed around a centralized architecture as a complete integrated solution that lets you manage all technologies. So that's the operating system, the network, and all the related subsystems. But it's more than just monitoring, as it also provides automation, which I'm going to talk about a lot more in a few minutes. But basically, the way MainView is designed, you just plug in the components you need, whether it's monitoring, automation, or even intelligent capping. So MainView is built on a centralized architecture, and it provides a single view and control across all your systems. And this makes it a lot easier to see what's happening in your environment, and therefore makes it possible to quickly detect and resolve problems. The central administration capability greatly simplifies the management of systems management, with the ability to manage and deploy alarms and automation rules directly to other systems. And these two attributes mean that MainView is very easy to use and can allow new and existing staff to be more effective and efficient in managing those critical systems. Also, because all the components, the monitoring and automation, all share the same platform, automation can be very tightly integrated with monitoring, and that helps to provide intelligent, proactive automation. Again, we'll get more into the details of that later. And then last but not least, efficiency. MainView makes highly efficient use of system resources, both in terms of actually sharing resources, single data collection, and does zip offloading. So some of the things that we've been doing with MainView, evolving that to meet the demands of today. So I talked earlier about the challenges of moving to the desired state of systems management and the importance of recognizing a problem earlier. The sooner you can detect it, the less impact it's going to have, and the easier it's going to be to fix it, whether you do that manually or automatically. And something else MainView provides is this capability through intelligent dynamic thresholds. Instead of setting a static threshold at a level higher than you expect to ever occur, which we know is going to basically mask problems that happen at times of lower usage, MainView has a self-learning capability which will determine what's normal for the time of day, the time of week, month, or year. And not only does it learn, it automatically adjusts your thresholds to match what it's learned. So this means you'll get alarms for abnormalities regardless of whether you're near the peak or not. It also means reducing false alarms because it's based on normal business cycles. And the other thing that dynamic thresholds these do is persistence checking, and so that's going to help weed out a spike versus a real exception. So some of the things that we're doing with MainView. And to get to this point, creating MainView alarms is very, very straightforward, and we have a simple alarm kind of wizard. So first of all, you simply say what you want to consider and when you want to do it. Perhaps you just want an alert or a trigger to be Monday through Friday and not at weekends, for example. Then you provide the conditions, such as the type of thing you want to test and the levels of threshold that you want to work with, or whether you want to use dynamic. You can also provide severity levels for the alarm, such as warning or critical. And then, finally, you get to define what's going to happen when that alarm condition is met. Maybe that's just a simple writing a message to the console, or perhaps you want to take advantage of the integration that we have with MainView Auto Operator, and you can send messages directly to Auto Operator based on alarms being triggered. The great thing about doing this is it allows you to pass rich contextual information into Auto Operator that it can use when it's taking its action. And that's really one of the big values of using MainView with MainView Auto Operators, that tight coupling and the ability to share information. And then, just to mention, the alarms can be defined and viewed either using the browser interface, which is what those screenshots are of, obviously, or you can also do it in 3270, depending on which you prefer. So I mentioned persistence just now, so I want to return to that and just spend a little bit more talking about what that really means. So the goal of persistence checking is to eliminate false alarms caused by short spikes. Generally speaking, there's only a problem if something doesn't immediately clear itself and is therefore a persistent problem. So with MainView, an alarm can be defined to start if a condition is true over a given number of samples. And then the alarm condition remains true until the persistence condition of the next lower severity has been reached. So for example, if an alarm is considered critical when the condition has been met for 7 out of 10 samples, and only major if it's been met for 5 out of 10 samples, once a condition has been signaled, it's going to remain critical until it's only been active for 5 of the 10 times, and then it becomes major. And just to kind of explain that in a little bit more detail, we can just kind of walk through an example here where we're sampling at different intervals. We're seeing the same problem, continually occurring, and then we're going to get to a point where it's flagged as a severe incident because it happened more than 7 times out of 10 in terms of sampling. So again, significantly improving the quality of the alarms and alerts that you're seeing. So I've talked a lot about early and accurate alarming, being critical to help, enable you to automate your ZeroS environment, starting with good information. So now I want to actually talk about the automation aspects itself and discuss how MainView provides intelligent automation to complement, the proactive alarming capabilities of the monitors that I've already talked about. So our view here really is that there's 4 aspects to MainView automation that correspond to what we call the automation maturity model that I mentioned right at the very beginning, as part of the agenda. And so when I look at the 4 different areas, starting at the top, the first thing we've got is basic event automation. That's probably the most widely used and the core component of automation. That's provided by our auto operator for ZeroS. The second is object management. That's sometimes referred to as resource management or state management, and that's provided by our total object manager component of auto operator for ZeroS. And then the third area down at the bottom of the chart there is console management, and that allows you to manage your consoles, the ZeroS consoles, and also the hardware management consoles, and that's provided by MainView Console Management. And then last but not least, we have subsystem management. This is specialized automation specifically around CICS, IMS, and MQ environments. And over the next few slides, I'm going to kind of talk about all of these in more detail, and we'll see how they all kind of play together to provide a comprehensive automation solution. So event management. As I said, this is really the sort of the core engine for automation. Based on rules you define, event management is driven by things like console messages, such as WTOs, timers, and commands. And also with MainView, it can be also driven directly by MainView alarms, which, as I said before, can pass rich data across to the automation, which is how we can provide much more intelligent automation. And responses to events can be are determined by fill in the blank panel-driven rules, and you can do simple things like suppressing messages, single action responses to events, all the way up to some pretty complex automation. And the goal of all of this, event management, is obviously to improve availability by responding immediately and accurately to messages, reducing risks by providing actions that comply with policies, and then basically empowering employees to work on other more critical tasks because the automation is taking care of all the rest of it. So I mentioned that rules can be created by panels. This makes it very, very easy to create rules as no coding is required. It also obviously means that they're much easier to maintain down the road. You don't have the problem of someone stumbling through somebody else's code and trying to figure out what they were trying to do. It also enables new users to quickly and accurately create automation without even having to learn Rex in the first place. And we generally see that even in shops with really highly complex automation demands, upwards of 80% of their automation can be handled with simple panel-based rules, which is a huge saving in time and effort of writing and maintaining the traditional code-based rules. Obviously, and of course, Auto Operator can also handle Rex-based rules. You can write and maintain them if you need them, but say over 80% of the time, shouldn't need to do that. Another very significant advantage of panel-based rules is their very low CPU overhead. So, the rules you define in Auto Operator panels don't just generate Rex that then runs. They actually run as a highly efficient part of the product itself, and obviously have much, much lower CPU. And that lower CPU usage helps out with lowering MLC bills too. So you're saving in many different ways with rules that run like that. And something else, when we convert customers from other automation products to Auto Operator, the results can actually be pretty amazing. And there's an example on here, where a large insurance company previously had used Rex to handle a multi-line WTO. When they switched to Auto Operator, they were able to implement that in a simple panel-based rule. And they saw a very, very significant reduction in the amount of CPU overhead for automation. They say 244%, quite an amazing difference just by changing one type of rule. So another area Auto Operator provides is centralized rule administration. And the idea being here is to make it very easy to manage and deploy rules. Here I have an example using the browser interface, but again, this is also available in 3270 for those of you who prefer that. But basically, you just select Rules Management from the menu, and you're presented with a view of all your rules. You can right-click on a rule, you get a menu, you have options to browse, edit, delete, and most importantly, deploy rules. I talked about panel-based utility quite a bit to edit and create rules, and on the right-hand side, you can see what that looks like. It's just a very, very simple fill in the blanks kind of form. You can scroll backwards and forwards to see what you've done before you save it. But everything's panel driven, whether it's defining the systems that you want to deploy the rules to, or going in and creating or changing rules. Everything is very, very, very simple panel-based way of going about things. So the next on our journey through the automation environment is object management. And this is sometimes referred to as resource management or state management, but it's all about managing the status of objects, such as started tasks, USS processes, and WLM resource states, and doing this across multiple systems. You simply define the desired status for each of your objects, along with any dependencies between those objects, and Auto Operator TOM, as we call it, Total Object Manager, does the rest. It obviously can increase availability by allowing faster startup and shutdown, and it reduces risk by making sure the correct start-stop commands are issued and respecting proper sequences and timings, so that if an object fails, it will automatically be properly restarted in line with all its dependents. And some of the other things you can do with this, it can expedite moving workloads to another system in the event of failover and needing to move on to a different system. And then the nice thing, with the graphical view of this is you've got the nice browser view, so it makes it easier to see the dependencies and understand what's going on in your system. So the third pillar of automation is console management, and this allows you to consolidate and automate system consoles. And it also provides secure access to the HMC, which allows for true end-to-end management of your environment. So some of the things it can do, employees are empowered by consolidating multiple ZOS consoles into a single desktop using a structured viewer, and that's regardless of where the systems are located. Here in this screenshot, you can see how multiple consoles are displayed in the main pane, with any priority messages being separated out in the top pane. So that allows someone to quickly see what's happening, and also provides the ability to launch down into a separate console window if you need to look at an individual system. And you can also do scroll back and searching on the content in any of those viewers to make it easier to manage a system. It's a web-based solution, so it's portable. Operators can share expertise by sharing sessions. They can cross-manage activity based on their current availability. And we have customers using it this way to manage their multiple worldwide data centers using a follow-the-sun operations model. Another key feature is peer review, which really helps if you've got less experienced operation staff. And then what it lets you do is have a more experienced operator review another's command input before it's actually submitted. So it can help avoid accidentally submitting incorrect commands and thereby risking your systems. It also provides a good training opportunity for that less experienced person, because they can leverage the experience of someone who knows more. The product also it reduces risk because it can continually monitor systems even during shutdown and startup. It runs on a Linux server, so it's available even when the mainframe systems aren't, so it gets to see everything. It also tracks commands issued by each user, so you've got full visibility into who's doing what for audit and for training. And then, lastly, because we know security is a very serious matter for everybody, this product, as you'd expect, is secured via solutions such as RACF, ACF2, or Top Secret. But we also support things like RSA tokens and access cards, PKI-based security. So we provide multi-factor authentication using those kinds of approaches. And one of the aspects of this, it can improve availability. It has its own automation built in, but it can also integrate with Auto Operator. And one particular area that can really make a big difference is in the area of IPLs. And we'll talk more about that in a couple of slides. So we can use modernization and innovation to help reduce costs. And here is a before and after picture of the command center for the same company. And you can quickly and easily see there's a big difference. And this is actually the BMC command center as it happens. So on the left, we see a typical mainframe center operations kind of setup, ZOS consoles all around the room at fixed locations. They're pretty much all on dedicated PCs with monitors. It's kind of very old-looking technology. When the operator's obviously not trying to constantly monitor all of those consoles at the same time, but they do need to interact with them, on occasion, and especially, of course, during an IPL kind of time. And when they do that, the user's got to go to the proper PC, find its keyboard, its mouse, find the right session, and then enter the right commands. It can be kind of cumbersome. Sessions are all pretty static. You can't easily move them to another PC. For things like disaster recovery or a fire drill, it requires a fair amount of considerable intervention there. So, all of that hardware obviously is taking up a lot of floor space, has high demands on both power and cooling, and you also have to license PC software on those machines. So all in all, a pretty expensive proposition and difficult to manage. On the right-hand side, you see with console management, significantly smaller floor space. And like I said, this is managing exactly the same footprint. Significantly less hardware, resulting in lower cooling, power costs. And she can manage 100 or so consoles from a single server. There's considerably less software costs in the picture as well. In fact, it's kind of an interesting story. We like this software so much, we used it in our data center. We ended up buying the company that made it, some years ago. So it's a pretty cool product. So now let's take a look at what we just talked about and see how it all works together. So, by leveraging console management, object management, and event management, you can get true end-to-end capability and specifically, simplify and streamline IPLs. So, the way it works with all these pieces in place, to start the process, you can just simply select an action in console management, one button IPL as we call it, to start an IPL. That would signal onboard automation such as auto operator to start the orderly process of shutting down all the started tasks and processes using a total object manager. When that's all complete, console management is going to detect that the onboard automation has terminated, and so continue terminating the LPAR by issuing commands such as ZOED, varying off XDF, all those kinds of things, and then finally deactivating the LPAR. And then when the LPAR is down, console management will access Hardware Management Console again, issue the commands to activate the LPAR, and then correctly respond to all the prompts along the way to get the LPAR up as fast as possible. And so when the LPAR is started, it will auto-load and start the onboard automation, which in turn is going to perform that orderly startup of all the started tasks and processes needed for the applications. And the nice thing is, because console management is sitting off on a Linux platform, it's able to oversee all of this activity. It sees all the early IPL messages, all the nib messages, and it can ensure that things are proceeding correctly. And the great thing about this automation is it can make rolling or cascading IPLs that much more efficient, as one IPL can just automatically follow the previous one, and each one of these is going to be running faster and error-free than you could ever hope to do in a manual kind of way. And we've seen, using this kind of technology, we've seen customers that save over 70% of their IPL time. 50% perhaps is more common, but we have seen numbers up around the 70% range. And all of this can translate to some fairly significant savings, typically in the sort of 7 to 18 minutes per IPL, which with one IPL might not seem a lot, but it can add up pretty quickly depending on how many LPARs you have. And obviously this obviously also correlates to application uptime. And what we see is some customers don't IPL as often as perhaps they would like because it takes too long. And so with this kind of capability, perhaps you can even IPL more often, and it's because it's much, much faster and much more accurate. Okay, so getting to the fourth pillar of automation is subsystem automation, not something that gets thought about as much, but BMC has specialized auto-operator editions that allow CICS, IMS, and MQ systems programmers to manage their own subsystem-specific automation using native event mechanisms. I mean things like looking at MQ event queues where some event information gets put, it doesn't get put on the console, say. And for CICS, looking at things like the CICS transient data queues, another place where CICS events can end up. So this really expands the reach of automation down into these specific domains, and again, provides very tight integration back into the corresponding main view monitor. So really, we can have the ability here to provide true solution kind of capability, and this is all independent from any ZOS automation that you might have in place as well. So subsystem-specific automation, just to kind of summarize the benefits. It continues to reduce risk and improve availability by allowing intelligent and proactive management of online systems, such as CICS, IMS, DB2, so forth. And because auto-operator and main view are built on the same platform, they have the same interface, they look exactly the same, and they share the same address space. All this means they're highly efficient and save MIPS, and not just through zip offloading, but because they're sharing resources as well. So one of the cornerstones of the overall main view strategy is to simplify the management of ZOS by providing intelligent solutions that leverage the strength of our monitoring and automation solutions. And over the last few years, we've actually rolled out an increasing number of solutions that come pre-configured, so you don't even have to write any alarms or rules to use them. And here's one example where we automatically activate a network packet trace when we detect a problem, and the trace continues until the problem ends, and then the trace is automatically stopped and saved. The advantage of this is that the trace is taken right when the problem occurs. there's no need, perhaps when someone comes in the next morning to try and recreate the problem or just, hope that it happens again, just in order to get the trace. So, this leads to faster problem resolution and obviously the resulting, higher system availability that goes with that. Another example that we've relatively recently provided, this is a very simple but powerful solution that lets you automatically restart VTEM applications as soon as the failure is detected. Again, with this situation, no alarms to write, no rules to create, just have to check a couple of boxes and it's done. And the last example I want to touch on, and there are quite a few more, but this one here is around CICS, where in the task collects it, you can automatically activate a kicks trace when a warning threshold is reached. Therefore, that's gathering trace data. So if the task then ultimately needs to be killed, perhaps because it's in a loop or something like that, trace data is going to be available to determine what happened. So another example of capturing data at the source and allowing for faster problem resolution. And again, the higher system availability that comes with that. So with that, it's time for our second poll. So Janine, I will turn it back over to you to do that, please.
Thank you, Paul. Okay, so as you can see, we have launched that second poll, and we're looking for your response to what are the barriers to automation for you. So go ahead and select those that apply. And then Paul was mentioning the BMC mainframe survey, and it is always one of our most popular webinars of the year. So that is coming up in November, and I'm going to go ahead and include the link to that webinar in our follow-up emails. So if you have any interest in the BMC mainframe survey, you can simply look for that email and register there, click there and go register. Like I say, it just happens to be one of the most popular webinars we do each year. And Paul, I just want to give this one more minute.
Yeah,
or
sure.
a few more seconds. It looks like we're not getting all the responses registered yet. But we kind of do have a clear winner. So I'm going to go ahead and send these results out to the audience. Okay.
Okay, great. Well, thanks everybody for responding. Just looking at that there, I think that pretty much matches what I was thinking. I didn't think many people were going to be fully automated. So there's some concern about skills, but by far the biggest was actually the general risk of maintaining automation, keeping it current, keeping it updated. So yeah, I guess that's kind of what I'm seeing from talking to customers, and then I guess we have a couple that basically want a person to have hands on or eyes on, and that's pretty common too. So thank you for that. So just have a few more slides here. So I just wanted to talk a little bit about some of our customers, and we've got a lot of customers using both MainView and Auto Operator for the day-to-day systems management and automation. But I just wanted to use one as an example. This is a large financial customer that we have, a very sophisticated customer, and they've got very extensive automation. It's a pretty large environment. There's 10 sysplexes, over 50 LPARs, and they've literally defined thousands of automation rules. I mean, it's a very large number. And even with this level of sophistication and complexity, well over 80% of their automation uses panel-defined rules. So I think that is a true testament to the power of what can be defined in rules and really limit the need for high maintenance, which we saw was a concern in the survey, and also the high overhead of Rex-based automation. And that 80% number is as I say, it's most customers can manage to automate at least that sort of amount just in panel-based rules. And something else that that we BMC continue to do to help customers move to even higher percentages of rule-based automation. We're continually evolving the panel-based rules to provide more capability. So we really want to try and further reduce the need for customers to be writing regs, because we're clearly hearing from customers that not something they want to do on an ongoing basis. And I think, from the survey, we saw that was the case too. So, just to give you an example of one customer using the product. So, before we get to the Q&A, I just wanted to do a quick summary, what I've talked about so far. So, we've got MainView's smart proactive alarms and auto-operators intelligent proactive automation. Hopefully I've shown you by kind of going through some examples and talking about those, how you can improve your application availability, but at the same time reducing risk. I mean, obviously they go hand in hand, you need to do both. And also how you can lower costs, with console consolidation capability of console management is one way of doing it, as well as reducing CPU, with highly efficient panel-based rules, as opposed to, relying extensively on Rex-based rules, as well as, the general efficiencies that I talked about within MainView and the automation solutions. And also, hopefully, how, you can empower your employees, with things like rule-based automation, so they don't have to learn Rex. And also, our approach to creating easy to use out-of-the-box solution capability. I gave you, just a couple of examples there, a few examples there. So they're sort of some of the things that we're doing, and hopefully that was helpful. So I guess we get to the Q&A section. So I guess Janine, can I turn that back over to you?
Great. We actually do have a number of questions, so let's get started. I will be replacing our longtime automation guru, who is retiring at the end of the year. I'm evaluating our existing automation software. What are the top things I need to look for in evaluating automation software?
Well, I think, some of the biggest things that we've seen are, the ease of managing automation, going forward. Obviously, you need to be able to do the things that you need to do, but I think, you need to think about how much Rex am I going to have to write, maintain, what's my efficiency, how easy is it to manage my alarms. I mean, a lot of people end up with a lot of alarms. I think, a solution that kind of reports on what you've set up, how it's being used, all that kind of thing. Again, just overall getting your arms around and really managing it. I think, you end up with situations, and probably if you're a new person coming into existing environment, there's probably a lot of automation that's been defined, and you don't even know if it's being used anymore, for example. And having tools that can help you understand that, I think would something I would look at anyway.
Great. With codeless automation, what would the level of complexity be?
That's a good question. I can't think of a good sort of single answer to that, but definitely getting beyond there's just the simple suppressing messages and sending replies, things like sending perhaps SNMP traps, doing email, opening tickets and systems. Some of the more complex things are automation that depends on other automation. Just some examples there. I mean, you can say, without sort of picking on a couple of those solid examples, you can definitely get pretty complex. But your imagination is kind of probably the limit.
Okay, here's one that kind of follows on the coattails of that. Automation without coding sounds cool. I am one of the new generation of mainframe folks. Point and click and tap is my world. However, I remain skeptical as we are talking about the mainframe. What kinds of automation are possible?
Again, it's a similar sort of answer. I mean, you can do so many things. I mean, you obviously issuing commands is one of the sort of main things that you can do, which gives you a lot of capability. Notifications, capturing, like some of the examples I gave you, like capturing trace data, sending it to somebody for analysis. You can string commands together. So again, quite a lot, and obviously each case is different. And it's just a matter of evaluating what your needs are and implementing them. And as I said, 80% of the time, automation we see over 80% of the time, it can absolutely be handled in panel-based rules.
Great. Okay, we have had few IPLs that have taken too long. Well, I should say we've had a few that have taken too long and have negatively impacted our availability SLA. Sorry if I'm kind of butchering this question. How can the MainView console management product reduce that time?
Well, good question. So like all automation, right? Automation is great because it responds immediately. There's no delay. So, if you've got the operators looking at the wrong screen or whatever, which is perhaps sometimes why, IPOs take a bit of time, automation is going to respond immediately, and it's going to respond with the correct response. So, you think if each one takes just a little while for the operators to get to response, that's a large part of the saving there. The fact that automation is providing the right responses, avoid any kind of problem with mistyping a command or typing in the wrong, pointing to the wrong volume or something like that. So it takes out all of those errors and really makes a big difference in terms of getting things done and getting them done properly the first time.
Okay. Before we go on to the next question, we do have a few more. If someone wants more information, now granted we've already provided some data sheets. Again, that is contained there in the Event Resources tab. But do we have a slide here, Paul, that gives them, like, say, the website or anything that they can go to for more information on these products?
Yes, we do.
Sure. Let's
yes,
go ahead and put that up.
Okay. So
and I'll.
This is
Perfect. Okay, I'll take the next question. Is automation part of the main view, or could that be bought as separate module for strictly automation?
Yeah, I mean, yes, you can buy auto operator without having the monitors. One of the nice things about MainView is it shares like a common infrastructure amongst all the components. So you would have the infrastructure there, but you don't have to buy MainView separately, kind of thing. So yeah, you could just get auto operator with ZOS, for example.
Great. Are there any reporting facilities, either for triggered alerts and alarms or for the actual configurement of the MainView environment, i.e. 15 rule sets, 250 rules?
Yeah, so yes, there are. I mean, there's an automation reporting capability in MainView Auto Operator. Provides quite a bit of information, things like when rules were last used, how often they're fired, that kind of thing. So there's a lot of information there. And then, with the we call them the sort of the deployable rules, and the rules that I showed you in there's a screenshot where where you just go in, click on rules menu, you get a list of all the rules. You can see all of those kinds of the information, configuration of the environment, the rules, rule sets, rules, that kind of thing. So yeah, you can absolutely. One of the things that we've actually been doing over the last couple of releases is adding more automation reporting capability and adding more in the area of making it easier to manage and deploy rules. So absolutely yes.
Perfect. Being able to have subsystem-specific automation is something I've not yet explored. Can your solution do that, specifically target IMS and MQ?
Yeah. There's specific versions for IMS kicks and MQ, and things like if you're looking at IMS, I think was the one you mentioned. It gives you the ability to access and work with IMS commands. Sort of specialized capability there. With CICS, it gives you access to transient data queues, Kicks journal. So yeah, it's basically allows you to automate. Because again, not all of these subsystems write all of their events to the console. They write them into specific places, so it gives you access to those, so you can build specific rules around them.
Great. Okay, you mentioned something called persistence. about alarm threshold evaluation. I would appreciate if you could explain that a little more.
Yeah, I mean, so persistence checking is really all about making sure that you're not just seeing a spike that drives an alarm and the spike goes away, and the problem's gone away with it. So it's all about over multiple samples, and say like over 10. How many times is that condition identified? So, for example, if it's we define a 7 out of 10 as being, a severe, very, like a major or a severe kind of condition. If it finds it's true 7 out of 10, that data alarm would be raised at that level of severity. If it was, say it was only 5 out of 10, then perhaps the alarm would be raised as a less critical kind of warning kind of condition. So it really gives you, it really gets rid of the false alarms, basically. What you don't want to see is a big spike that lasts virtually no time, but it gets caught in monitoring and then it's gone, kind of thing. So it's really about making sure that you're not seeing false alarms, because again, as I mentioned, you get situations where you've always got red lights on all over the place, but everyone just basically says, oh yeah, it's always like that, we're just going to ignore it, kind of thing. It helps get away from that sort of thing.
Perfect. Okay, seeing no more questions, Paul has been generous enough to provide his email address there. So if you do think of a question following the webinar, I'm sure he would invite you to go ahead and send that his way. I want to thank everyone for attending today's webinar, and I especially want to thank Paul for sharing his expertise with us today. As mentioned, we will be sending out a link to the recording of today's webinar. We'll also put the link to the next BMC webinar coming up in November if you're interested in getting the results of the annual mainframe survey. That concludes our webinar. Thanks again, and have a great day.